All right, so quadratic functions. A couple things to go over. Some skills that we should remember, but it's fine if we don't. It's always good to review. So for example, substitution. So if you have an equation, or an expression, I should say, example 3x squared minus 2x plus 1, and you wanted to solve for when x equals minus 3. All we need to do is replace all of the x's with minus 3. So it would be, for example, 3 times x, which is minus 3, and it's sometimes easier to visualize if we put brackets, and then squared, minus 2, and then x again, so I'll put brackets, minus 3, plus 1. Okay, then we just evaluate. So minus 3 squared is 9. That's a double negative. And this is also a double negative, so that becomes plus 6, and then plus 1. 3 times 9 is 27, plus 6 plus 1 gives us 34. Okay, so that's all there is to that. We also used to do a lot of table of values. So what we would do is we would use this substitution technique by substituting different values of x into an equation. So for example, 3x squared, we'd substitute minus 2 into x. So we'd have 3 times minus 2 squared, which would give us 12. If we substituted minus 1, we would get 3. You substitute 0, well, 0 in that case, and so on, 3 and 12. And then coordinates, if we were to graph this, coordinates we would write as an ordered pair, always starting with x comma y, written inside of parentheses. So in this case, our x would be minus 2, and our y would be what we solved for, 12. Okay, and plotting those points, remember x is our horizontal axis, so minus 2 would be here, and then go up to 12 for y, and there would be our first point. Then we can do the same with the other points. So here we have minus 1 and 3, which would be minus 1 and 3, 0 and 0, be here, 1 and 3, and 2 and 12. You can probably notice a pattern, right? 12, 3, 0, 3, 12, as we move over. And then it's just a matter of connecting the dots. You can see this looks like a parabola we're probably familiar with from grade 10. Okay. Let me just pause there, see if anyone has any questions. All right, so example number 2. Now if you look at this equation, you might be able to see that this is actually a linear equation. It's not a quadratic equation. Linear equations is more grade 9. So we're not going to be doing any linear equations in grade 11, but the skills we have with linear equations and, for example, finding the X and Y-Intercept, which is what this example is all about, we are going to do with quadratics, because any graph you make may have an X or Y-intercept. So we'll look at X and Y-intercepts in quadratics, but I'll teach you how to do that when we get there. Lowever, it's pretty much the same steps. So to find the Y-intercept, if you look at your graph, just move this up, look at your graph, if you have a curve or a straight line or anything, when it crosses this axis, the value of x is 0. So to figure out where it crosses that axis, we're just going to do substitution. And we're going to substitute x equals 0. So if we look at this equation, and we just substitute 0 in for x, we'll have 3 times x, which is 0, plus 4y, which equals 12. 3 times 0 is just 0, so that's just going to disappear. And we're left with 4y equals 12. So again, now this is where the skills of rearranging equations will also come into play. Okay, a lot of the math skills we go over are going to appear over and over again in everything we do. So in order to isolate for y then, since it's being multiplied by 4, divide both sides by 4, and we'll get y equal to 3. And so we know our x-intercept then, sorry, our y-intercept is 0 and 3. That's our coordinate right here. Now to find the x-intercept, whatever sort of, keep moving this, whatever graph you have, if it goes through the x-axis, whatever point it goes to, just see that the x-axis is on y equals 0. So, to figure out where it crosses the x-axis, we're going to let y equals 0 in the equation above. So again, substitution, we have 3x plus 4y, but for y, we're going to write 0. And that's going to equal 12. Now in this case, 4 times 0 is 0. That's going to all disappear, and we're left with 3x equals 12. Again, we need to isolate for x. If it's being multiplied by 3, we do the reverse operation and divide by 3, and to make sure we do it to both sides. 3 over 3 is 1, so we're left with x equals 4. So our x-intercept is 4 and 0, which would be right here. And since we know this is a linear equation, linear equations are great. Once you have 2 points, then you can just connect them in a straight line. Okay, we won't be graphing linear equations, but we will be graphing quadratic equations. And finding intercepts is going to be one of the important things that we do. Right? So that's it for this lesson. It's going to be